Hello. All right, so I think I'm going to go, if I stand, I'm going to be pacing around a lot, which could be good. Or I could sit. I'm not sure yet. Give it a start. All right, so thank you for the introduction. I'm excited to be here. Ever since I heard about this idea of applied computer science, it's been something very close to my heart. And hopefully you'll see why by the end of this presentation. So blurring the physical and digital. So my first sort of question is where do we spend our lives? So I think it's easy to think of some of the physical places where we spend our lives, the airports and parks and trains, nightclubs of the world. These are all spaces where our lives go on from day to day. And in the grocery stores and the hospitals, and the kitchens and the banks. But in addition, we are really embodied and present in these spaces as well. So even right now, as I'm talking to you, some of you are thinking about your Instagram account, or thinking about Facebook, or Twitter, or Fortnite, I don't know, could be anything. But the main thing is that from a young age, I sort of realized that these things were both real and meaningful in my life. You know, what happens right now is I work with the people who build the physical world, and they sort of look down their nose at the digital world. And then I go and work with the digital companies of the world, and they're kind of like, oh, I guess we still exist in physical space for now. And I love this quote from Paolo Antonelli, who's a curator at the MoMA, where she talks about how this is affecting our minds, that our mind is this sort of soup between the physical and digital, right? And one of the promises to me of created realities is an ability to fuse these now disparate things together in a more holistic way. So, for a long time in computing, people have been talking about how content is king. But really, you need context to scale computing. So if you start at the sort of mainframe, we used to have computers that you would have to go to, right? It was in some other building. They could do things, but you physically had to walk over to meet where the computer was. And that was still created a revolution. And then the next revolution happened when you could have a computer in your home, right? So that led to an order of magnitude scale when you could have a personal computer in your own home. And one more of these happened, which is this idea of mobile computing, where now you can take it to the restaurant, you can be in the elevator, you can take the train. All of these are places where you can have this computation. So what if there was something that was even more ubiquitous than this thing in your pocket? So just out of curiosity, how many people think we'll have cell phones in 10 years? Some people, okay. I mean, one thing that's interesting is having seen a little bit of this change happen, I don't take it as a given that we would. In 10 years, we could have a completely new platform, and we could all be on that new platform. What that is up for a lot of debate, but I'm definitely open to the fact that that could happen. So how does this happen? Are people familiar with this phrase, software eats the world? It was a quote from Mark Andreessen, who was one of the founders of Netscape and later was a venture capitalist. And he was talking about how everything in our world is being sort of consumed and rethought as software. And so one way you can see this is in our environment is everything in our environments. So whether you're at home or the office, anything that was paper, someone now makes a screen that size. So every piece of paper in our world and even the sort of, this is like a great combination here, with the whiteboard here and the projector here. But also, you know, these are the size of Post-it notes, and tablets are the size of notebooks. And software's done an incredible job just gobbling up everything that was on paper. And next, it's coming for all the objects, right? So I'm kind of using a broad set of examples here to talk about how some of them are very obvious and some not so obvious. Like, I love, this is a very high-tech digital pedometer for biking. But its interface and its way I relate to it as an object is very analog. This is, to me, this is an Omada, it's a beautiful design. But even now, you think of all of these networked items, and in this case, it's replacing an existing object. Right? We already had these parking meters, and now we have these digital ones. But every once in a while, you get these strange new things, like, what was this object that became a Cheez-It button? Do people know this object?
Amazon Dash button, I'm pretty sure.
Yeah, but it's interesting, like, the digital version of this sort of replaced the existing thing. This is just like, they were like, what if the physical world had internet buttons? And we could put them around. So it's not always eating the world in the way that we expect. And the part that I'm sort of closest to is now we have mixed reality, which is really eating the environment. So in this example, these are examples of using computer vision at the satellite scale, right? So from satellites, and I've seen this used a few times in industry. So one example is, let's say you're like a big box retailer, you're like Target, and you're curious how many people are shopping at Costco. Oh, sorry, I meant as Target, but yes, you do. And what they'll do is they'll use satellites to track all the cars in the parking lot, coming in and out of the parking lot, in order to figure out over time all of you that are shopping at each store, right? And as that gets more sophisticated, they don't just track the number of cars, but maybe even identify exactly which car, right? So we have this happening from space down, and then also from down here on Earth out, right? Cars are starting to sense and map our physical environments more and more. And this is some examples of surface reconstruction, and this as well, which are similar to what I worked on later in the HoloLens, which I'll get to in a little bit. So let me back up for a second and talk about how I got interested in all of this stuff. So I started after graduate school. Before graduate school, I'd done a lot of screen-based design. And at one point, I just was done working with screens, but I didn't know what that meant. I still wanted to do interaction design. I just had sort of explored what I wanted to with screen-based interfaces. And I had a chance to join an interdisciplinary firm in New York called the Rockwell Group. And I joined as a creative technologist, one of these ambiguous job titles. And the idea was that I would think about, in these big cross-disciplinary teams, the technology. So the Rockwell Group designed big events, so they designed the Academy Awards a few times. But what was different about them in terms of architecture and design is that they would do end-to-end experiences. So like when they designed the Nobu restaurants or the W hotel brand, it went from like logo to room design to architecture. We would consult with the chef around the taste of the food. All those things sort of came together. And I really had a great time doing that because I'd never sort of collaborated with so many different kinds of people. So these are just some different shots of the studio during collaborations, different kinds of projects we were working on. So we made a lot of mess and then would clean it up after each project. One part of working at the Rockwell Group really stuck with me, which is this idea about collaboration with its comfort and complexity. So, and this is something I really recommend to people when you're looking to collaborate with someone, to find people as different from you as possible. I think you get a lot out of that type of collaboration. You know, it's like, I was just visiting a software company, and I was using as a joke, I was like, collaboration isn't like C++ developers and Java developers finally working together. It's like, go work with like a dance choreographer or go work with a chef. And it will really change both of your views of work. And so that's something I've taken with me. So when I got there, I met this guy named James Titchener, and he and I sort of had this perfect gel together because I, on the left, had worked on a lot of software kind of things, interactive installation stuff, and was just barely breaking out of the screen, you know, using projection and computer vision. Whereas James came from the world of architecture and electronics, and he couldn't write any software. And he always joked he's the only interaction designer who couldn't make a website. But he and I hit it off at the Rockwell group, and we sort of noticed something, which was that in these companies, people would feel really free to collaborate until it came to technology, right? So like they'd feel free to work with materials and experiment, but technology, there was always someone telling them things weren't possible or telling them that no one had ever done that before, and so that was a reason not to do something, which in a lot of other disciplines, that would be a reason to try to do something. And we had this idea, what if we founded a lab that was dedicated to this relationship of the physical and digital, and could work alongside primarily architects, but many different kinds of product designers and experience designers to think about how to weave technology into the group. So this was our little team in New York City, and we kind of came up with this model where we talked about the interaction of objects, environments, people, and stories. So this model I still use today to think about environments and interactive environments. So a lot of what we wanted to do was to think about how we could start to give physical things digital properties, right? So our first project in 2006, which is a long time ago, was to make a set of networked lights. So we had this idea of, what if all of the lights in the building were on a mesh network and they could all affect each other? What if we could give this sort of like digital property of networks to physical lights? So we started by creating this mesh network of lights, and when you pick them up, they send signals to each other. But a key part of it was that they don't have to just all behave the same. They can all have each have their own behavior and just be affected by inputs in any part of the system. And we started working with that on the architectural scale of light, where we could think, how could we modify from relatively small controls the architectural scale lighting? And we designed these objects, which was pre-Arduino, but used the same chip as the Arduino. And you can see, if you know anything about electronics, don't look too closely. But this was something we built because we wanted to be able to try these things firsthand. And we built these cubes, and at the time, these cubes cost us about $1,000 a piece to make. Now, we could probably make these cubes for $6 to $8. So a bunch of great things have happened in the last 10 years to bring the cost of these types of projects down. Also, we learned a lot about how to make things more affordable. So that started on the product scale. And the next project we worked on was the entry for the Venice Biennale. And in this case, it was a very different kind of project. So we got approached by the curators. The theme of the Biennale was architecture beyond building. So the idea was that what are the things outside of building that influence architecture? And in particular, they are influenced by film, right? The spaces within film that have been depicted, for instance, in science fiction. So as we were collaborating, we had this idea that we wanted to sample from these films, which we curated and got the rights to, which, asked me afterwards, that was by far the hardest part of the project, getting the rights to like 30 Hollywood films. But we started with this idea that we wanted to be able to sample them. We wanted people to be able to build their own architecture from the samples of film. So this is sort of what the installation looked like in the end, where you can actually see the eye. I'm pretty sure that's the eye of Neo from the Matrix. But you can see that when people stand within the space, it would begin to construct these fragments of film into architectures. So this kind of architecture beyond building. And what's weird for me now when I look at this project is it reminds me so much of like mixed reality kind of work. But at the time it was very much in the space. So here's a little video that just shows some of it live in medium resolution. So on the back of each of these screens was each of the films playing independently. So if you walk to the other side of the screen, you could see the film that was being sampled live. And at the time, the only way we could figure out how to sample the video live was to write it in write all of our software in C++ to get the sort of performance we needed out of the video. So this was written in kind of a early precursor to open frameworks. Has anyone here ever used open frameworks? It's a great creative coding library for C++. So the reason we did that, and this was sort of my first experiment in that kind of work, was that we wanted to be able to have this sample real time so that when people went through the space, it would construct these things out of the live film samples. After completing that project, we learned a lot from doing that, and we're really excited to sort of deploy that on a more permanent scale, that kind of installation. And at the same time, we were approached about a hotel in Las Vegas. So there's a hotel called the Cosmopolitan in Las Vegas. Has anyone ever been there? Oh, awesome. So it's, we had a really interesting time with this project. The history of it's quite strange. Something I'll tell this room, but don't pass it on. I worked on the experience design of the most profitable nightclub in the world because of this project. I don't keep that in my portfolio because it was insane. This is a different part of the project. This is one where we came into the West Lobby space, and the first thing we were sort of confronted with was basically these 8 concrete columns. And cross-disciplinary team, right? So a bunch of people suggested, hey, you know what we should do, architects? Let's get rid of all these columns in the way. They're really just sort of ruining the space. And they said, well, those hold the building up, so we're gonna need to keep those. But actually that joke or that moment led to some of the inspiration of what we did, because then we thought, well, how could we get rid of them? Could we somehow dematerialize the columns? Could we somehow make it feel like you didn't even realize that these huge concrete columns were in the space? So that was one part of the inspiration. And then the second part was, at the time in Las Vegas, there was this sort of rule that as much money as you could spend on some crazy spectacle, it would come back to you. So like there was almost no limit to what people would spend. And but it became weird because imagine you spent a lot of money, for instance, making a giant fountain, okay? The first 8 times you see that fountain, it's incredible, right? But what happens to the next 10 times that you see that fountain? How do they keep that fountain feeling refreshed over a decade? It's a real challenge. And so we were like, well, that sounds like something the internet does really well, right? Digital things have evolved to be dynamic and have their content constantly updated. And in a moment's notice, we could transform the space, right? But they were quite skeptical of that idea initially. And part of it was because, you know, it couldn't feel like walking into a bunch of screens, basically. It had to feel like a space. and the space had to feel transformative. So we had this idea, we would clad the columns. We designed a special, like sort of half silver aged mirror and a special mechanism to try to hide the screens in the columns. And then we mirrored the ceiling and the floor in order to sort of extend the effect. And so what happened in the end was that we made this installation which you could come to, and each time you come, you'd have the same sense that you were in the same place, but you'd have a new experience. And a key part of how we did that was that we knew this software had to be generative. We knew if every time you came in and it was playing a video that was just looping, you would go crazy. I don't know if anyone's ever had the misfortune of working in a situation or being in a situation with like a looping soundtrack or a looping TV. It really makes you feel like you're losing your mind. And part of that is like a joke we would always say is, you know, interactive installations, you have to walk some fine lines because sometimes people will come in and when they understand how the installation works, they sort of dismiss it. And how to keep a space alive over a really long period of time. So this is run continuously since 2009. Part of it we knew had to be generative and also had to be beyond us, right? So we needed to help build the platform, but then we needed to sign up artists and designers to make content for this space. So right away we worked with the Art Production Fund, the Bitforms Gallery, what is their name? Digital Kitchen, which is like a motion graphics agency, to think about how to make content for this. But the first thing we'd give them is, they would say, great, we make tons of content, what's the scale? And we'd say, well, the smallest resolution we'll accept is 44,000 by 4,000 pixels. That's like the lowest resolution. And they're like, what? Like, how do you even output that? So what we had to do is sort of take on the challenge of not just making the installation, but making the infrastructure so that people could make content for it, which meant helping people through that process. So in this case, we wrote things in open frameworks, and I'll give you an example. We did, through Bitforms, we worked with some digital artists, and were able to help them sort of walk through the process of what it meant to scale their generative work to this size. And a big thing was that we would actually, if they weren't able to come on site, we would record videos walking through the space, send them back and forth to sort of tweak everything to make sure that it had the right feel. So again, almost all of these are written in open frameworks. There's actually some written in processing. And this is a great example where we started to take more from the techniques of video games in terms of rendering graphics to think about how we could optimize for the scale. So you saw the spheres, or in this case, we did some around the seasons. And one sort of secret feature of this is that embedded in the ceiling, we used the same type of computer vision cameras that we used in the Venice project to sense where people were in the space. But here we have them tuned to be incredibly subtle because a little bit goes a long way in Las Vegas. And so you don't need this thing, like in this case, you can see this deer forming. The deer actually form where people congregate in the space and then disappear. But if you just stand and like wave your hands like you might do in Vegas to try to get it to react, it won't react that way. And that's very much on purpose. And there was a joke we used to talk about with generative work where we wanted, no one goes to the ocean, or I hope you don't do this. No, people don't go to the ocean and they're like, okay, now I've seen it. I never need to come back, right? It's like the ocean always looks like the ocean, but it's also ever changing. And that was part of our inspiration for what it meant to have this generative work in this space. And yeah, I mean, the other interesting thing about it is that it's exclusively reserved for digital art, which was something we were quite proud of to sort of push that. Like they get a lot of pressure during CES, the big electronics thing. People offer them just insane amounts of money to put like whatever logos up on these screens. But they've really done a pretty good job of like protecting its value and its meaning in the space. Yeah. So as that project was concluding, always trying to think of other ways to make our lives difficult, we thought, how can we do this at a more urban scale? And we got a commission, an art commission from the 01 Art Festival in San Jose, California. And it was funny because this is a, who is the architect of this building? It's escaping me right now. Uh-oh. Anyway, I'll think of it in a minute. But anyway, we had seen the building, we hadn't visited yet, and we were really excited thinking that it was going to sort of feel like New York City where we lived. And when we went, it was San Jose, California, which is different, right? Different thing. And one of the things is that there's very little natural pedestrian traffic into the city hall. And our idea was that this is the City Hall of San Jose. What if we could make it, first of all, a beacon so that from a distance you would be drawn to go participate in the sort of plaza of the City Hall. And at the same time, at the same time, once you got down there, we wanted to have an ability to sort of interact at a scale that made it feel like you were affecting City Hall. So we set up a variety of installations on the base. So you see someone playing hopscotch there, shouting into the megaphone their thoughts about the world or the government or whatever it might be. And we had a variety of these stations, and each station, when you would interact with it, would release these abstract sort of cubes from the base of the building. You can see them shooting up the facade. And there was a bunch of things that I really enjoyed about this project, and one of them was that from very far away, you could look and see the City Hall and know exactly how much activity was there, right? Like how many people are over there, what's happening, should I go over there? And it was the first time I ever got to work on that kind of urban scale, and I hope I get to, again, more, because it really changed how people used that plaza for the time that it was installed. And at the same time, this sort of feeling as just an individual coming to City Hall, that you could make a small interaction that could shoot up the surface of a building, it's something like, it makes everyone feel like a sort of toddler in a good way, where you're just like, you know when a toddler can like move something for the first time, and they're just like, I'm a hero, I can like move this block from here to here. There's something very interesting about that interaction, and we saw people sort of able to do that at the scale of the base of the project. And it was tricky to figure out what we wanted to have sort of animate on this surface, because initially we tried some experiments with live data that people could set up, and as you would expect, the first things they sent up were really crazy. So we were like, okay, we need to abstract this in some way where they still understand they're doing it, but it's not like, you know, something really inappropriate on the City Hall right away. And then we did one more just for the sort of hackers of that area. We made an open USB plug, and you could go and make your own devices and plug them in and animate things up the wall. And we didn't think anyone would do it. In fact, the first time we saw someone connect, we were like slightly scared, because we're like, are they gonna break our installation? You know, we'd sort of published plans for how to do it before the installation, but we had a few people actually make things and come and set them up so they could interact. And for 8 years, we continued doing these interactive installations. And a thing that came out of this, we got approached by Google, who was interested in trying to make an operating system for spaces, right? So like what would that mean? What would an operating system for buildings be? And one of the things we built for them is sort of APIs for all their spaces. So here, this is actually the web-based editor for these stairs. So anyone from anywhere in the world can connect an API, see roughly what it's going to look like spatially. That was really important to us because if you're not physically in front of these stairs, like how do you know what that's going to look like as you're working on it? So we used like 3JS to build all of these parts out, to have that editable system. And those operate many of the Google buildings to this day. A few of these projects I just want to take a quick note of. This is one of the larger scale ones we did for the Google Cultural Institute in Paris, where we started to work in more detail with their data to create a space around a specific data set that they had. But this one on the upper right, I love to talk about because it helps talk about the scale of architecture projects. We bid this project 8 years before it happened. We were like, we have this idea with switchable glass where we can have light pass through and be the screen, right? So sunlight could pass through the switchable glass and cast shadow onto the sidewalk or inside the building. And it took 8 years for it to happen. I mean, it doesn't mean 8 continuous years, but architecture sometimes is a really long process. And so I've never seen that project in real life. I worked on it for a very long time. It's in New York City now. And it's permanent, so I'm sure I'll get to see it someday, but I kind of excited about it. And there's a reason, so wait, one last thing about this is that as we were working on all these projects, it was very important to us to create open source software to sort of give back to the community that we had been drawing so much inspiration from. So we've done that in a few ways. We have this software called TSPS, which is a toolkit for sensing people in spaces, which we used for like environmental sensing of people in space. We have this software based on interactive spaces called Space Brew. And this lets you easily connect things made in different technologies together as inputs and outputs. But I think we felt like we would often write into our contracts, actually, that for a group like the Cosmopolitan, the hotel group, they don't really care about owning a lot of software. That's not their business. But they were very happy to fund and help us release open source software. Whereas when we worked with Google, that was a lot trickier. We did release software with them, which is called Google Interactive Spaces. But some of the other software we worked on, their just sort of default thing was like, we're not going to be able to share it. And so it was quite a different process, but we were really invested in giving back to the community with those tools. So 8 years go by of doing these projects, and James and I got a strange phone call that said, hey, we want to come talk to you about a new project. And we thought it was like going to be like an experience center or something. So we went and met with them, and we were like, what's the project? And they said, we can't tell you. And that wasn't very encouraging. But then they said, hey, how about tomorrow, get on a flight to Seattle? So we did, because we thought, oh, maybe it's just a center they can't talk about yet or something. So we go there, and basically they said, hey, we see everything you've been doing. What if we could start to do the other thing? What if we could take digital things and start to give them physical properties? Like, what would that mean? And we weren't really sure what they were exactly talking about, but we were definitely intrigued by that idea, so much so that we left our lab that we had started and we moved to Seattle to work on this project. And the project became the Microsoft HoloLens, and it took. So we were sort of involved from the sort of kind of like incubation scale to the release of the first dev kit. And a lot of what we're doing in this project, like this is a great example, is taking a digital thing and giving it a physical location in the world. And if you were to ask me what's the interesting part of HoloLens, that's what I would say. I would say I can take this thing, whether it's digital or physical, I can put it right here, and I can interact with it spatially as if it was physically there, which means if I want to look at the other side of it, I don't have to like go like this and like rotate it around. I can actually just get up and look at this side of it, right? So why is that interesting? I mean, the interesting thing is that your whole life you've been doing that. Your whole life you've been interacting with these objects. If you can use that same interaction paradigm, you don't really have to teach people anything to use this kind of computing, right? All the skills they've learned about like, if I want to see the other side of this object, what are my options? I could rotate it. I could get up. I could look. I can apply all those same learnings. And then I'll get into more of these details. So I really think that if you pay close attention to the design of these products, you can see the vision that people have for them in the world. Like, where do they think this thing sits in the world? How many people have tried a HoloLens? Okay, fair amount. So imagine, for me, I feel like where we are in mixed reality is sort of roughly at the mainframe era. Okay? So there's a long way to go in this stuff. But how could we embed some of what we believed in into a first version of this product? Well, the first thing was that it had to be able to understand the environment. So a HoloLens, from when you turn it on, wherever it's looking, it scans that part of the environment and saves a map of it. And as you look, then it looks at this part and adds to the map, right? And when I look back, it goes, hey, has anything changed? If it has, update it. And if it hasn't, then keep the map the way it is. And so from when you put on a device and start to walk around, you're building a kind of inside-out map of the world, right? Which is called outside-in tracking. And this was a really important thing for us, that like you didn't have to rely on other external sensors or other ways of understanding the world, but it would be able to recognize and try to build a map from itself. The second part, which was probably the hardest technically, was that we wanted it to be transparent. So at the time, it was pretty straightforward to make opaque device, but one of our big bets in sort of mixed reality was that there's a lot of value to just adding to the world versus having to recreate all of it. One of the things, if you work in VR a lot, that is both exciting and challenging is that you have to draw every pixel, right? Which means like, oh, the physics here don't quite look right. Like, what do I do? Do I rewrite the physics engine? That sounds hard. You know, what do I do? Because you're controlling every pixel, whereas in mixed reality, we could say, what if we could add to the parts of the world and create this sort of unified front? And as a designer, one of the most challenging parts for me was that we had to, a lot of people think of design as like the output of something, right? Like a poster or a game, those are the sort of outputs of design. But how do you design the input? Like, how do you design what you should sense and what you should listen to? And how do you, and then they asked us, like, decide on that because we had to bake it into the hardware, which was a really exciting and challenging part of the collaboration, was figuring out like how all the sensors would work, how should they work, what should they sense, and embedding them into this this set of chips. Now, one of the dreams of mixed reality is that you can begin to play with the physical world and the digital world seamlessly. And so I'm going to show a video that I just appreciate from one of the projects we did that is about finding interesting things in the world, adding digital elements, and then recording them.
I'm a huge fan of the dinosaur hologram. There are very few situations that aren't improved by a holograph. I'm a huge fan of the dinosaur hologram. There are very few situations that aren't improved by a holographic goat.
I think my favorite actiongram is still our zombie named Ned. He's a great actor.
Actiongram is part of the first wave of launch applications for HoloLens.
The main point of Actiongram is to allow a user to tell a story by putting holograms in their world and then recording them and then share that.
So we give you a huge collection of holographic characters and props and tools, and you can use that to put holograms into the story that you want to tell.
My most popular video on YouTube, one of my friends spent hours adding effects. In the future, with holograms, I could maybe do those things in an afternoon. If you don't know how to use VFX or you don't have actor friends, you can't make the type of content that Actiongram is going to allow you to be able to make.
Our app is focused on humorous content, things that you might want to share online. But there's so many other forms of storytelling, educational storytelling, or instructional storytelling, and I think that's really exciting for developers.
No question in my mind that a small garage development team could easily make a HoloLens application. It's really no different than developing for any other mobile platform. The differences are in how you solve your problems rather than on the technical side.
We're on the cutting edge of this becoming the way people consume media and create media. I'm just so excited to watch that progress.
So the interesting part about that to me was that, like, I love the record player zombie one because it's like this mixture of like, what can I see in my real world? How do I design my real world environment? And then how can holographic material change that or augment that? So after 4 years of working on that, after the dev kit was out, I worked for another year on all the Windows mixed reality headsets, so all the like VR kind of era devices that they made. And then I decided I missed these kind of radical collaborations. And so 2 years ago, I left to just collaborate with people. And that's all I've been doing for 2 years. So I'm not going to show all those projects because they're super random. But I'll talk about a few. So one thing I noticed with all these big companies, and this is probably something to be thinking about, is that computing changed a lot, right? So you have traditionally have like this human-computer interaction, and we've had for a long time humans and environments. So what I actually have to call conventional reality, just to keep all the realities straight. But we have this really new era between computer and environment that gives us all these perception abilities, and kind of mixed reality sits right at the middle. And for me, mixed reality has a really broad definition. For me, the stuff I did in the Cosmopolitan is the same kind of work that I do now in HoloLens or other mixed reality platforms, right? It's about how you create that entire interactive environment. So that's great because that means I can draw from all these disciplines, right? I can start to collaborate with, people in theater, people in exhibit design. In fact, when I meet with people working on VR, the first thing I tell them is like, stop looking at VR and start looking at exhibition design. Exhibition design is incredible as inspiration for VR kind of work. And then, so this is an example of a collaboration. I've been working with a school in Denmark on a toolkit to make it easier to mix physical computing with mixed reality. So we have this toolkit called Yushi, and it works with a Raspberry Pi. So you hook up the sensors, like right away you can see it recognizes the Raspberry Pi. And actually, these satellites are all the Wi-Fi networks that the Raspberry Pi is seeing when you plug it in. So that's how you know it's working. And then here's some crazy projects that I've been working on with students around how to blur the physical and digital. This one's very straightforward to me, where it helps explain the sort of concept. So there's a physical side, and by placing a physical cube there, you can block this virtual ball when they're playing. And at the same time, if that ball hits the sort of digital pins, it physically knocks the bowling pins over using solenoids. Really simple, but like how do you make these little interaction loops so that you can really start to play with that physical virtual boundary? Perhaps a more fun example, this group decided to make physical interfaces for their favorite mobile apps. So the first one they worked on was endless scroll. So how could they simulate what endless scroll felt like in Instagram? And they used this wheel. And so the next one, I'll see if anyone, you try to guess what the app is. Ready? Nice, who said that? Amazing, yeah. So they, first of all, this part I'm not sure about. They decided that the haptics of Tinder were like a slimy mango, so they carved a mango face. So you're like touching this kind of slimy face, and then people are watching you sort of vote on the, sort of select these Tinder profiles. But it really did, giving a physicality to this experience really transformed it in an unusual way. So again, using the same toolkit. Which brings me to the sort of latest collaboration I'm working on. So last thing I'm going to talk about. So I was really inspired by the sci-fi writer William Gibson talking about the future. And he was like, what will seem really weird in the future? What will we look back on and think like, that was unusual, we spent a lot of time on that? And his answer was that we had this really strong need to distinguish between the real and the virtual, right? Like we spend a lot of time talking about that, or a lot of our designs center around that. Like what is that? In the future, it might seem crazy. And then recently, because I work with a lot of researchers, it's been happening to me where I'm like losing a little bit of my sense of what is real and virtual in certain contexts. And I've thought, okay, if this is happening, let's jump ahead and say, what does design look like? What does making things look like when it's indistinguishable? So one of these is a real person, one of them is a generated person, right? And hopefully the video is bad enough that you can't tell which one is which yet. But for me, when I'm looking at this stuff and I'm working on some of these things with researchers, I think, well, what should design be like in that context? And it's led to a lot of really great ideas about how design could work. So a big part of it is that you sort of return to some basics around like making sure that you're taking care of people in your experiences, making sure that people have a home base which they can feel free to explore from, but can return to and feel safe. And this sort of collaboration of figuring out what would design look like when we aren't able to distinguish between the real and virtual is my sort of latest collaboration I'm right in the middle of. That's it.